All right, so we're solving a problem involving logarithms. One of the rules of logarithms, if we are adding logarithms that have the same base, in this case the base is 4, the x minus 4 and the x plus 4, since those are being added, that means we would multiply those, have them equal to x minus 4 times x plus 4 gives us x squared minus 16. By simplifying those. And then we know a logarithm is an exponent. Again, a logarithm is an exponent. So this x squared minus 16 is the number, 4 is the base, 2 is the exponent, so the x squared minus 16 equals 4 to the power 2. Simplifying that, 4 squared is 16. When the minus 16 changes sides, it becomes plus 16. So 4 squared, which is 16, plus another 16 gives us the 32. So if x squared is 32, x is going to be equal to 5, or plus or minus 5.66 to 2 decimal places.
Wait, how'd you get 5.66?
Square root 32.
Why did you square it?
How do you undo squaring? Square root.
Why is it plus minus?
Because you can square a negative and get positive. Like if you think about if x squared is 4. 2 squared is 4, but also negative 4 is. Everybody okay with part C? Got it, Jesse? All right. Part D. Two numbers differ by 5. Prove that the difference of their squares is a multiple of 5. So I'd like to show you 2 different ways to do it. First way, I'm going to call the first number x and the second number y. So the difference of their squares, x squared minus y squared. A multiple of 5 meaning it's going to be equal to 5 times the quantity x plus y. As long as this comes out to be a whole number answer, I will have proved it. So x squared minus y squared, this being a difference of 2 squares, gives me x plus y times the quantity x minus y equals 5 times the quantity x plus y. I divided both sides by x plus y, so that means that x minus y equals 5. And if the difference of 2 numbers is 5, those are definitely numbers that differ by 5. Another way to do it is a way I saw some of you guys do it. I'm going to call the first number x and the second number x plus 5. Here we've got the difference of their squares. Again, if that equals to 5 times their sum, expanding brackets, combining like terms, I get 10x plus 25 equals itself. This is an identity. Therefore, it's been proved if you get something being equal to itself. And the last one, part E. Solve the equation. The hint, let u be 4 to the power x. So if this is 4 to the power x, and that's u, well, that's got to be u squared. So this lends itself to being a quadratic. U squared equals 9u minus 20, setting it equal to 0. Factorizing, u is 5, u equals 4. That'll get you a unistructural mark of u. because this is 9 times 4x, and they told you to let the u be 4 to the power x. So that gives me the 9u. And if u can be 5 or 4, u can be either 5 or 4, that means if u is 4 to the power x, then our 4 to the x, which is u is 5 or 4. So that means 4 to the x can be 5 or 4 to the x can be 4.
So it can be either.
Yep, it's a quadratic.
All right.
Yeah, it's a quadratic. So, solving there, 4 to the power x is 5. When your unknown is the power, take the log of both sides. We know that the x comes out front. X times log of 4 equals log 5. Dividing both sides by log 4, x is 1.161. And the last one, 4 to the x equals 4. There you really didn't even need to use the logarithms. 4 to what power is 4? Yeah, x has got to be 1. But if you wanted to do it just to have the practice, that would be that.